Everybody go to Canvas and go to your lesson for the day. Click on the concurrency lesson in Canvas and let's talk about what concurrency is. Okay? So go to Canvas, navigate to Canvas, go to concurrency, and let's talk about what concurrency is. Right? We've been using it loosely for the last 2 weeks, right? But concurrency, keep in mind, concurrency is we have multiple cores on our computers, on our iPhones. Concurrency is making use of those multiple cores in a way that is helpful for our users. Concurrency is performing multiple activities at once, right? So we have your iPhone, your iPhone probably has 6 cores, right? Right? Some other iPhones might have 4 cores. So each of those cores are able to do work concurrently. Concurrently means at the same time, right? We're not all coming in here. We're all coming in here concurrently, right? We're all coming in here, well, almost at the same time, not exactly at the same time. But we're not waiting for one person to come in, then somebody else comes in. We're all coming in together. Does that make sense? We're not waiting for one person to come in, then the next person comes in, then the next person comes in. Concurrency is having many things happen at once. It would be a bad user experience if a user is scrolling a list of Instagram posts and they would have to wait. They can't scroll anymore. They have to wait mid-scroll to let an image load in order for them to keep scrolling. This would not be concurrent. Concurrency means in programming, especially for iOS development, the user could move on with their UI while something else loads. So many things are happening at once, right? The user posts an image to Instagram, that's going out to Instagram. The user goes out to a different view to see other feeds. At the same time, the user is clicking on a favorite icon to favorite somebody's photo. Many activities, multitasking, right? So really write down, if you have to write down one thing, say that concurrency is many things happening at the same time. Or many tasks happening at the same time. And why is this possible? This is possible because we have multiple cores in our devices. The more cores you have, the more work you could do, the more work your computer could do. Typical example, yesterday, a Minnie came, her fan is going haywire. Her fan and her computer just couldn't handle the work anymore, right? Our computers probably have 4 cores, right, if I'm not mistaken, right? Our MacBooks have 4 cores. Anybody correct me if I'm wrong here? Right? So at some point, all those cores will be working over time, right? I have Slack running. I have Xcode running, which is very heavily resourced there. I have Chrome running, which is also a performance hog there. I have all those pieces of software working. They're all working concurrently. Chrome is not waiting for us to finish our Xcode for it to load a browser. Everybody with me? Right? So everything is happening at the same time with the multiple cores that we have. That's why the more cores you have, the less of a workload you see your computer doing, because there's more cores for it to be able to dispatch work to, right? So if I have 8 cores on my machine, at any one time, maybe I have 2 cores that's empty, right? So the workload could get distributed. If you have one person doing all the hard labor in a construction site, that person is going to fall down and collapse, right? You need more people to come in to make that job easier. The more people you have, the more cores you have, the easier your processor will be at the end of the day. Your computer won't be overloaded. The fan won't be going like a vacuum cleaner, right? Because you have multiple cores in the machine, they're able to be dispatched to. You're not the one dispatching to the core. The operating system is the one dispatching the work. Everybody with me? I'm not saying, oh, use core 5. I'm not doing that, right? It's up to the operating system. I say, I want to do some Chrome browsing. It decides which core to use. Everybody? So this is concurrency. Concurrency is the ability for multiple things to happen at the same time. Right? So that'll take us into iOS programming. iOS makes concurrency possible through the library called Grand Central Dispatch. Grand Central Dispatch, or GCD, is the library, or you could say is the concurrent library in iOS. It's that library that enables us to do concurrent code, right? So GCD for short, know how to explain what GCD is, know what GCD is. GCD is that library that allows us to write concurrent code in iOS. Not just iOS, all Apple platforms, right? So you have your Apple Watch, right? You have your tvOS, you have your macOS, you have your iOS, now you have your iPadOS, right? All those operating systems, we have GCD to allow us to write concurrent code. Especially a low resource platform like the watch, right? You really want to write concurrent code there because the user needs to be able to use the UI at any point. You don't want that UI to be stuttering. Right? So the smaller the device, the less cores the device, the more you have to be careful as to how you dispatch work in your program.
Alex,
Yes?
you said Grand Central Dispatch is specific to Apple devices across the board?
Yes.
So would the same concept be called something different for different platforms?
Yes. Like every platform has their own way of handling concurrency. For example, JavaScript handles concurrency using async await. Right? Hopefully at some point we'll have something very similar to async await. It's more streamlined. It's a better concurrent model. Right? It would be in 5, but I think in 6, maybe in 6.0 Swift, we might have like a async await methodology. But it is available to us like third-party libraries. As we get further into iOS development and we import third-party libraries into our applications, there's third-party libraries that does stuff like that, like async await. There's PromiseKit that does something very similar, right? But as far as our concurrency, right now what we have is GCD, and GCD got introduced since iOS 4, right? So as we had more cores, we figured, hey, we have to do multitasking. We introduced GCD, and now we have GCD at our disposal. Okay. So we spoke about what concurrency is. Let's talk about what thread is. Because again, we've been using main thread. We've seen what that looked like. I even think we did use a background thread at some point, but now let's introduce it again more formally. So think of a thread like a pathway. It's a pathway for execution. Think about it like a train track, right? We have a train track here. If you could take a look at our image that we have here, right? We have multiple threads. Here we have 2 threads. This is like a GitHub model, but think about it as a train track model, right? We have a train track. We have an express lane. Think of the express lane like the UI, the user interface of your application. Think of that express lane as the UI. Don't think about MTA right now, right? Our express lane is always empty. There's always trains just zooming by. There's no congestion on our express lane. Our express lane is in our ideal world. An express lane should be express, right? You don't go to Trader Joe's, you go to the express lane, there's somebody with like 100 items. It's express, 10 items, get out, right? So in iOS, let's think of threads like expressways or tracks that our code could get executed on. Think of the expressway as the UI. The UI should always be free to do anything the user wants. The user wants to click a button, there should be no blocking there. When I click that button, it should turn my heart on Instagram from empty to red. Everybody with me? I'm not waiting for that to change. I'm not waiting seconds. The minute the user has to wait seconds on any UI, they get frustrated, right? If I upload my post and there's nothing telling me anything, I'm just waiting at this empty screen there, I get frustrated, right? Because I have my business to do. I want to see more feeds or whatever it is. So I might end up deleting your app if it really gets to that point where I'm fed up, right? Like there's no interaction, you're blocking my UI, you're blocking me from doing all the things while something is loaded. Anytime you're doing that, that's bad experience, right? You scroll in, the user can't scroll anymore because images are loaded. Bad experience. That expressway needs to be free. That expressway we call in GCD the main thread. The main thread is where all UI needs to be updated. That main thread needs to be empty, no blocking. There's no database loading on my main thread. There's no freights, there's no train freights going on my expressway. That expressway, I'm just flying through. So think of a thread as a thread of execution, a path of execution. There's multiple threads, there's multiple threading. iOS is multi-threaded. It's multi-threaded because we have multiple cores, right? So the operating system is able to say, hey, I'm doing heavy load. I could go to this CPU here, which is empty, so I could do image processing on that CPU, right? And the way we programmers, the way we handle concurrency, using GCD, using the libraries that we have, is dispatch queue. We use dispatch queue to create, well, we don't create, explicitly we do not create threads. We're able to create a queue, and the queue decides which thread it goes to. Right? So I say dispatch queue main, it goes where it needs to go. I'm not the one deciding you go to core 5 or core 4. The tools we have is dispatch queue. We're able to say dispatch queue main, because I'm doing some UI updates. I'm able to say dispatch queue global, get off the main thread. You could go on some other core, whatever, but do not go on the main thread. Dispatch queue is the class that we have in GCD that enables us to dispatch work. Right? Here we say the main queue is responsible for all the UI components of your application. We've seen it before with table views. We've seen it before with the purple era. The purple era came about as Xcode 9 or 8, one of those versions. Because before the app would just crash, now it crashes and it shows you, hopefully, a purple line. It shows you a purple line, you're doing something wrong on the wrong thread. You should be on the main thread. So again, everything UI is on the main thread. Everything UI, you dispatch queue, that main. And here we talk about, main thread. We said what main thread does. Anything global is away from the main thread. Anything global is a track that's not on the express track anymore. It's not express, it's one of the ternary tracks, right? It's a track off my main thread. Let's see. You are not updated, are you? Okay. Come back to that. So keep in mind, let's look at our photo. Let's look at thread 1. Think of thread 1 like some database work. Some database work I'm doing. I'm no longer on my express lane. Now I'm on a different thread. I'm on a global thread. I'm no longer on my express line because I'm doing some heavy work. Anytime you're doing heavy work, get it off the main thread. Everybody? Okay? And the way we do that is using, the way we get heavy work done is using a global queue. We use a global queue to do heavy processing. Heavy processing could be I'm getting an image from the web, right? I'm doing some network calls. I'm opening up a database. I'm accessing a file. Anything that has to do with processing, extra work the user does not care about. In the aspect of UI elements, the user doesn't care that you're grabbing some image from some image URL. All what they care about is the image showing up, right? That image showing up is UI. What you do to get that image, that's not on the main queue. That's on a global queue, right? So everything you're doing with UI is on the main queue. Anything you're doing as far as processing, database work, image processing, file access, right? Input, output from file systems, all that is on a global queue, okay? And let's talk about the global queues that we have. Let me actually get more access here. So global, 1 second, dispatch queue, QoS. All right. Okay. Let's talk about the ways we could dispatch globally. We have different priorities when it comes to global dispatch. The priorities we have user interactive. Can we all see in the back? 1 second. Can we all see in the back now? Mel, can you see? Okay, so we have what's known as quality of service classes. What does that mean? Basically, that means what is the priority of that global dispatch, right? Is it of high priority? Is it medium priority? Is it low priority? So those are priority. You could think about them as priority queues, right? Which work is more important for the user? So Apple gives us what's known as quality of service classes. We could use global with the default case. Like we don't care of the priority. We could say dispatch it globally. I don't care about the priority of it. But anytime you care about the priority of it, meaning, does it have to do with updating some animation, right? If it has to do with updating some animation, I would use the user interactive priority, right? So here it says the quality service class for user interactive tasks such as animations. You're animating something, but it's still basically on the main queue, but it has a priority class called user interactive. If the user clicks on, for example, my Instagram like button, this is known as user initiated. The user initiated that action. If the user initiated some action, you have to use user initiated as that global priority there. This is on the dispatch queue global, right? So back in the lesson, I had to divert away from the lesson for a second because here in our lesson, we have resources from Way Wonderlic, right? But here we have 2 priority classes, but there's more than 2 priority classes. So I went over to the API to show us all the priority classes we have. And we have 6 priority classes, right? But 2 of them are not used explicitly, right? Because if you say global without specifying a priority, global is default, okay? But user interactive, think about user interactive as an animation, right? There's an animation, there's a ball going across the screen. If you want to globally dispatch it, it's user interactive. I'm introducing the theory behind everything. We'll see what the demo looks like. Right? Next, we said if the user clicks on a button and they want an image to load, for example, like I click on a button and I want a new image to load in some app, the user initiated the action. It's called user initiated. Default is if you don't provide any QoS, if you do not provide any quality of service, default is the use case there. Utility is from the network. I open up my Instagram app, right? It's been idle. I open up my Instagram app. I want to get new photos in. I want to get new feeds in from the network. I'm querying from the network. If I'm querying from the network, it's a utility QoS. It's a utility quality of service. Yes? If I am getting data from the network. Querying, I'm asking the API. Right? So the user is not the one that initiated that. My app initiated that. So that's a utility QoS. Right? QoS stands for quality of service. If you're doing anything that's heavy work, some database cleanup, right? The user open up a database, well, not the user open up a database, but your app opens up a database to get the user's information, whatever it is. That needs to go on a background priority. Background priority is the lowest priority. Everybody with me? Background priority is the lowest priority. Here it says maintenance and cleanup, right? The user doesn't care about that, right? That's low priority. It happens in the background. So those are the quality of service priorities. So whenever we say we want to do work outside of the main thread, we are using one of those priorities. If we don't care about the priority, we simply say global and we do not specify an argument. Everybody with me? We'll see what that looks like in code. That takes us to talking about synchronous versus asynchronous. What's the difference? That gets asked a lot on interviews, by the way. Right? So synchronous is people are entering the door, but only one person could enter the door at a time. Everybody with me? Right? So if Brendan is entering the door, nobody else could enter that door. That door is considered blocked. Only one person could enter that door at a time. So think of a world where one person enters the door at a time. That's synchronous. Right? So as Brendan enters the door, somebody else enters the door, but nobody else could enter. Two people cannot enter the door at the same time. One task gets done. That task is blocking everything else. Nobody else could enter that door. So here we say synchronous code will run immediately and will block everything else until it finishes. When Brendan enters that door, he's the only one entering that door. Nobody else could enter that door until he's entered the door fully. Then somebody else could enter the door. So this is synchronous. Okay? On the other hand, asynchronous, I could enter the door, somebody else could enter the door, or I could make a phone call. Let's use a phone call analogy. I could make a phone call, leave a message to somebody, to some help desk person, say, I have a problem with my computer. Right? I'm not waiting on the phone until I get that person. I left a message. When the person has that time, they get back to me. I'm not waiting for anything. Nothing is being blocked here. So I make my phone call. I have problems with my computer. I go on with my day. Right? It's not like the cable guy. You have to like wait there for him. That's a blocking feature, right? There's nothing you can do. You just got to wait for that cable person to come. Right? That person is blocking your day. You want to go on with your day. But if you dropped off the keys to the cable guy, or if you dropped off your keys to Time Warner, you could go to work. You don't care about anything else. Nothing is blocking your day. That would be asynchronous, right? That would be awesome. But anytime you're waiting on somebody, you're waiting on that person to do something before you yourself able to do any other work, that is synchronous. Somebody's blocking your activity. I can't go on with my day. I can't go on with my work. You're on a team, somebody's working on the login view controller. You cannot keep working on your profile view because that person is not done. That person is blocking you. But if everybody has their own task to do and nobody relies on the other person, that's asynchronous. Everything is happening, nobody's waiting on somebody else. That's more efficient. But there's times where synchronous is what you want to do. You want to block everything until that piece of job is done. Right? So there's scenarios for both of them. But remember, synchronous blocks. Asynchronous does not block. Asynchronous makes a task. When that task is complete, it gets a callback. It gets a completion handler. Everybody, we've seen asynchronous code with our URL session. That's asynchronous. I make a call to the network. Whenever the images are ready, I get back a callback. I get a completion handler saying, hey, my data is ready. I could do what I want with my data. Right? I'm not waiting for the data before I do anything else in my app. I could go ahead and scroll my table view, see comments. When the images are ready, they show up. This is asynchronous. So whenever you're doing networking, that's asynchronous. You don't want to do synchronous networking. You want to do asynchronous networking. You make a task, you make a URL session task. When it's done, you get a callback, you update your UI. Does that make sense? Any questions about that? Okay, so that's the introduction of concurrency here. We'll talk more about concurrency. And the GCD library is vast, it's big. There's a lot of things there. But the big classes we'll be using is dispatch queue. Dispatch queue main is the big one we'll be using to update UI. Anytime you want to do some background task that doesn't have to do with UI, you would use dispatch queue global. And based on the quality of service that you want, you figure if it's user initiated, if it's utility, or if it's background. Okay? We would never explicitly use user interactive because that's basically a main thread sort of action there. But no background, no user initiated, no utility. So utility would be, I'm getting images for a table view. I'm not waiting. The data gets fetched. When the data is ready, my table view images loads up. That would be user initiated. Sorry, that would be utility. Utility is getting data from the network. User initiated, the user clicks on a button. The user initiated a request. Okay? Yes?
So why is user initiated part of the global queue when it's technically like so
You mean user interactive?
user initiated? It says queue used for tasks that are initiated for the UI, right?
Yeah, for UI, like the user clicks a button.
Yeah, but that's under global queue.
Yeah, it's on the global queue because the user, that's not it's a UI, it has to do with UI, but not direct UI. Like the user clicks on a button, you have like a spinner going on, user initiated, you get back your data. Okay? The actual querying part of it is not UI. Does that make sense? The initiated part is they click the button. Cool. All right. I slacked out a demo project. Everybody has it? All right, so let's go to that project and see what it looks like. So for now, make sure you're running on an iPhone 11 Pro Max, and let's run the app and test it out. App. So I have my application here. Let's zoom here. I'm able to scroll, right? We're able to scroll and see the description, correct? Yes, everybody's able to scroll, correct? Okay. Go ahead and click. Do you see the load image? Do we see the load image, the bar banana? Go ahead and click on the load image and let's scroll. Can we scroll? But keep scrolling. Now you could scroll, right? You were able to scroll when the image came back. Everybody? Go ahead and click load image again and try to scroll. Can we scroll? So at this point here, we're blocking the main thread. Everybody? This particular app here is blocking the main thread. The user is not able to see anything unless that image comes back. Was everybody able to emulate what I just asked for? What I just said there? Like, were we able to click on load image and scroll at the same time? No, correct? So here we are blocking the main thread, right? So this particular app is not concurrent. I cannot do multiple things at the same time. I cannot click on load image and scroll at the same time. So this is not concurrent. Any questions about that? So at a high level, not high level, when I say high level, by the way, I mean details will come later, but we're talking about the details right now. Here, we are talking about concurrency. This particular application is not concurrent. The definition of concurrent says, if the user clicks on the load image, they're still able to scroll. This is the definition of it. But our app has just broken that definition. This is a bad app, right? 1 star, delete. So let's go ahead and fix it and make it concurrent. Okay? Let's go ahead and fix the code and make it concurrent. Any questions before we move on? Yes? This would be an example of synchronous, right? I cannot do anything until the image is loaded. So Chelsea was saying, is this synchronous? Yes, it is. Because right now I'm waiting for the image to load before I'm able to scroll. Bad user experience, bad UX.
Oh, I wasn't able to
It couldn't find a device. Are you selecting iPhone, like some simulator on your?
I think I was a generic.
Let me make sure that I have. You might have to change your Xcode, your iOS. So go over here, Oscar. Not here. They keep changing things, and I keep looking for things. Where is it? 13. Zoom in here, Oscar.
Is that the signing or the resource tab?
1 second. So you see where it says general here?
Oh, yeah.
So click on general, and right where it says targets, Do you see 13.2?
Yeah.
Change it to like 13.0.
Yeah.
Change it to 13.0. Are you able to?
Oh yeah.
Now you should be able to create the simulators. Good? Cool.
I'm curious.
Yes, George?
How did you get the words? Were the words part of the URL?
Yeah.
So with the picture came off. No.
Yeah, it's like today. That's today's astronomy photo from NASA.
No, I'm confused. With the picture came all of this description?
Yeah. Not the picture. Those are two things. It's a label and it's an image view.
Oh, because I came over here and I didn't see it.
This?
You put it
Oh no, there's no label. There's no label. There's only an image. Only the image we're changing. Tiffany, the label is hard coded. The label is on the storyboard. Yeah. Like all that is part of the storyboard. Because today we only focus on concurrency, so I don't want to like build out. I don't want to build out a UI today. We're only talking about concurrency, and I want to talk about it, fix it, know what it is, so we could move on. Any questions? Okay, so let's see what the code is doing. So if we go to the view controller, let's go to the view controller here. Let's focus on load image. So we have an IB action, load image. Do we see that? All right, so we have an URL here. We have a URL string. We're making sure that it's a valid URL. We use our do catch because our data contents of can throw an error, right? If it throws an error, we catch the error on line 30. Great. But what are we doing on line 26? On line 26, this is what's blocking the main thread. This particular line of code is doing some data processing. It's doing a lot of work. Everybody. So here, this is doing a lot of work here. Image, not just image processing, but it's also querying the URL, querying the URL online resource, and downloading to a data object. Right? That's doing a lot of work. And that particular line of code is synchronous. This is very dangerous. It's easy, but it's very dangerous. So this one line of code, by the way, we need to refactor that and use URL session. We won't do it today. But ideally, anytime, keep that in mind. Let's write it down here. So anytime you are querying an online source, do not use data contents of. Okay? Use URL session instead. Okay? This particular API, data contents of, is ideal. It's ideal if the data is local, right? We have our JSON file, which we've used before, right? It's local. This is fine. This is recommended. But anytime you want to go query a web service or a web online data, do not use data contents of. So keep in mind, this code here will refactor it at some point to use URL session. But today we're not talking about URL session. We're only talking about concurrency. Everybody with me? Okay? But either way, this is doing a lot of work. A lot of work is happening there. So anytime you catch yourself where you're doing a lot of work, processing work, get off the main thread. One way we could know what thread we're on, you might not need this, but just to let us know that it's available, we could say if thread dot is main thread, bless you, print on the main thread. Whenever the application runs, we on the main thread, right? Our applications runs, in default, it's on the main thread. Everybody with me? I run my app, I'm on the main thread. That's what I have available. It's the developer's job to start dispatching to different queues, right? I'm dispatching to different queues as I have more work to do. If I have heavy work to do, I dispatch globally. But on default, I have the main thread. That's what I have. So if we run our application right now, actually, let's just, let's move that here and put it in viewed load. So we're not like, just put it in viewed load, sorry. Put this particular code in viewed load. So we see what thread we are on when the app runs. So thread here is its own class. That's an older class. It's not recommended that we create our own threads, but back in Objective-C days, you could have created your own thread. But Swift developers, again, it's a more high-level language. Those are more abstract away from us. So here we saw that we were on the main thread. Everybody got the printout in the console that they're on the main thread? Yes? Right. So here we know now, let's go down. We know now this data needs to get off the main thread. This is doing too much work. It's blocking my UI. Okay? This is not something you could, as a beginning developer, if you're following some tutorial, whatever, you come across data content, you're like, wow, that's cool. One line, I get my data, I get my image. There's also an image data too that we'll see. Well, right here, right? Those are nice, 2 lines, as opposed to our URL session, right? How many lines we have there? You guys love that one, right? It's like, what, 15 lines, 10 lines, whatever it is. But here you have 1 line, you get your data back, you're done. But you're blocking the main thread, and this is not the API recommended by Apple to use. Okay? So 2 things. One thing we'll address today, we'll get off the main thread. And keep in mind that if you're getting data from online, what are you using? URL session. Okay? Very good. All right, so let's fix this. I'll keep that here and say not concurrent. Blocks the main thread. User is not able to scroll as image is loading. Okay? Okay, cool. So we will keep this code here. I'll just comment it out. We'll keep it here for our references. And we will do it concurrently. So let's do that. First off, let's go ahead and dispatch to a global queue. Dispatch to a global queue, get off the main thread. So now we should know main thread is UI. Main thread is basically UI, right? You're doing UI, you're on the main thread. And UI is anything the user sees or able to interact with. So let's go ahead and dispatch a global queue here. So we'll say dispatch queue. Dispatch queue is the class that we use. On dispatch queue here, we'll say global. And as I said before, we have 2 globals here. The global without the argument is default, which we spoke about earlier. Default just doesn't care about priority. If we care about priority, we would use the QoS, or quality of service, global method. Okay? So here we'll go ahead, we'll use global QoS here. If you don't care about the priority that the work is get done on. Like if you don't care, it's as far as like, is it a low priority, if it's a high priority, as far as getting the data back, not even the data back, but figure you're standing in a line for a movie, do you care about getting a ticket for a seating area, or do you just don't care about sitting at all? Like you sit wherever you want to sit, right? You'll get to the theater, but you don't care where you sit, right? So that's like global without the QoS, right? I get to the movie, I sit wherever I want to sit. If you're going to watch Frozen 2 with your kids, you probably want to get seated, right? I comment out everything except our URL. And I'm still inside the function, yeah.
So you would use this, you would use the QoS if you do care about.
The priority.
But if that's if you specify it, meaning like you want it specifically to be no priority.
Yes, we are. With the QoS classes, we'll be using that. So in this particular case here, the user clicks on a button. If the user clicks on a button, what priority am I using?
Okay, and that.
No, what priority am I using?
Okay, but either way, it doesn't stop. Oh, you're asking me? Oh, sorry, high priority? If you click on a button?
We
Or
have-
low priority because it's on this.
We have user initiated, we have utility, we have background. Which one are you using?
Background. So this is all low, though.
Background is, again, the user clicks on a button.
Right, and they can keep going, right? And still doing this thing while they keep.
Yes.
So that would be, if it's user initiated, then is that high priority?
User initiated is one of the higher priorities, yes. So that would be user initiated.
User initiated.
Exactly. All right, so let me actually go ahead and slack out something that you guys should, because there's a thin line sometimes between what's what here. It's actually on our lesson, but let's see here. It's an image. Read over this, by the way, when you get a second. This is a really good article. It's on the lesson. I'll get it eventually. Yes.
So QoS is only applied to local.
Yes.
queues.
Yes. Main thread is main thread.
There's no way to prioritize anything in main thread.
No.
Anything is already considered high priority.
Exactly. Everything is on the UI, doesn't care about, and there's no priority there. Everybody, let's see. So here, this is what I'm talking about. Ray Wunderlich wrote an awesome article here about what the QoSs are. And there's also a WWDC video I'll send out to us for us to watch. We need to start watching WWDC videos. Actually, let's see. GCD, WWDC video. Modernizing, there you go. No, not 2017. That's not it. Building responsive. Yeah, I think it's this one. Please watch this video. I'm going to send you the link on your leisure. Please watch this video. It's a good one. It talks about the QoSs, and we developers on the Apple platform, we need to start getting used to watching WWDC videos. What is WWDC? What is WWDC? Anybody knows? Worldwide Developer Conference. This is the conference. This is the mecca of the year for Apple developers. This is where Apple introduces new software. This is where Swift got introduced. This is where Swift UI got introduced, right? All those things there, that's where that happens. And engineers from Apple that write the frameworks, they come and talk about the frameworks. And those are the videos that people write books from. They take those videos and they write books from those videos. So this particular video here talks about GCD and being responsive. So it's like 43 minutes. Please watch it on your leisure time here. This is where Ray Wunderlich grabbed his resources for that particular article. So let's go, this guy. All right, so we have the video to watch. And here, anytime you catch yourself not remembering what the QoSs are, you can come back to this article. And the one we're after is user initiated, right? User initiates is a synchronous task. It's an asynchronous task from the UI. Use them when the user is waiting for immediate results. I want my image. I want my image, I don't want it to block the main thread. The priority is user initiated. Okay? Let us get this image here. What's that? Oh, you mean the screenshot?
Yeah.
Shift Command 4. Shift Command 4, a selected screenshot. So there we go. Here is the. Okay, perfect. So we have our QoSs. Let's get back to our app. Let's dispatch. So back in our application, we'll say dispatch here. Dispatch queue, right, is the class that we need. That's the class from GCD, Grand Central Dispatch. Grand Central Dispatch is the concurrent model in iOS. Dispatch global, we said. And we said we'll specify your QoS. If you don't want to specify your QoS, you simply use global without parameters. But I want a QoS. And we said it's user initiated. Right? Next part, we have to specify, is it synchronous? Do we want this work to be done synchronously? Or do we want this work to be done asynchronously? And we know what synchronous is, right? It's going to block. So here we want to dispatch this asynchronously. So we'll say dot async. Okay? And it's a closure. In our closure, we'll do our heavy lifting. So here we'll do our hard work, our heavy processing, our data processing of the main thread. And now we could do our do catch here because we're about to get our data. We're about to get our image data using the data class, contents of now. And we have our URL. Remember, it throws, so we need to mark it as a try.
So we can still do content of.
Yeah, for now we're using that. I want to talk about URL session tomorrow. Okay. Today we are not focusing on the exact API that we use. We just want it to be concurrent. Okay. So here we have image data. This is great. And if we have an error, we simply say print contents of error. So we have our image data. Great. Let's get the image. This is still not UI work, by the way. We're just getting the image using UI image. And here we have data, and we have our image data. Great. Now we have the image. We're about to update the UI. If I want to update the UI, what do I need? Should I update the UI here? Where am I updating the UI? I heard main somewhere. Main, right? So a mini says I need to dispatch back to main. I got the image I want, right? I'm on a background thread. Now I need to go back to the main thread to update my UI. So here we have the image. We have the image from the data. We have the image from data. We have the image converted from data. Now we need to update the UI. And again, we said anytime we update in a UI, where should we be? On the main thread. Anytime we update in the UI, we need to be on the main thread. Let's actually see what happens if we don't do that. What's my thing called? Planet image view, that image. equal to image. All right, let's run the app again. I click on my load image. Right? It's not blocking anymore, but now I got the purple error, and I also have a crash log. Everybody? We've seen that purple error before. We introduced what that purple error was. Now Xcode is telling us what? What is it telling us? Let's click on the error. UI image must be used from the main thread only. Do we see that? Do we all see that? Do we all see that purple error? And if we scroll up here in the console, if we scroll up right above the 0 thread here, if we scroll up right before 0, what does it say? Background thread on UI view of subclass is not supported and may result in unexpected and insidious behavior. Insidious. Apple don't want you to be insidious. Right? Okay? So we need to fix that. How do we fix that? We go back on the main thread. Very good. So now let's go to the main thread. So to go back to the main thread, we say dispatch.main. And again, we'll do asynchronous here. Why don't we use sync? We don't want to block. If we use sync here, we're actually going to crash. Right? Because actually we won't crash, but we don't want to do it synchronously. Right? But if you're doing synchronously, I might show us what that looks like. If you're doing it synchronously and you're on the main thread at the same time, this is going to create a deadlock. Okay? So here we do it asynchronously. We take our code and run the app again. I have an F. F for fun. Okay, run your app again. You could run directly. Run also checks for errors. And click on our load image and scroll, right? We could scroll, there's no problem here. We're not getting blocked anymore. You did not get the image? Did you set the image on the here? Self? Uh-huh. Did you?
It takes some time to load.
Yeah, as long as you, it load, yeah, the internet, everything, right? But at this point, the user is still able to scroll. Everybody with me? Okay? Say that again. You mean the purple error? The purple error we got. Let me tell you. Let's walk through it again. So before we dispatch back to main, we got a purple error because here we're no longer on the main thread. As a matter of fact, we could even test it. Let's see if we're on the main thread, right? I could say if let, well not if let, but if thread dot is main thread, and print on main thread, else print not on the main thread, right? So let's actually comment that out. So Amelie wants to go over why we got a purple error and why we need to go back to the main thread. Everybody with me? Go back, run your application. Run your application and put in that comment here. If we're on the main thread, it will say on main thread. If we're not, it will say not on the main thread. Okay? So let's see what that looks like. So I click on my load image. It says not on the main thread here, right? And if we're not on the main thread, Apple, well not Apple, but the SDK knows that you're not on the main thread and you're about to update some UI. Okay? Right? This is forbidden. Exactly. It's not optional. So Amelie, to go back again, please, thank you for asking that question. It's not optional whether I go to the background thread or not to update my UI. I have to, it's required.
So somehow I accidentally pressed
It could crash the app. It could crash the app. Like for example, when we did the UI alert controller the other day, it crashed the app. Right when we had our what were we doing? We were doing the URL session, and we had like an error come up, and we were doing the alert controller on a background because we were coming back from an asynchronous call. It crashed the app. Right? Because again, it's not recommended. Not even recommended. It's not optional. It's required that you do every UI update on the main thread.
The code you had before was on the main thread, and now
The code I had, yeah, very good. All those are good questions. So Luba was saying the code we had before here, it was on the main thread, right? Because this is a synchronous API, right? It was designed to get the data back right away, almost instantaneously, right? But what we were trying to do is do more work than the API was designed for. It was still on the main thread, but now it was blocking the main thread. But now we explicitly, we ourselves, we put it on a background thread by global, by dispatch global. Global.
that takes it off the
Exactly.
thread, and then the dispatch queue that main brings it back.
Yes. So we're the ones doing that work there. We're like, hey, we're about to do some image processing, go to the background or go to a different thread to get off the expressway. And when we're about to update our UI, come back to the main thread.
So is there another way to determine when one that says printing out?
Is there, you're the developer, so you know the APIs you use, right? For example, URL session documents it. A good API would document what it is, like if it's asynchronous or not. When I introduce URL session, it shows us that it's an asynchronous call. So the minute you say URL session, we're not the ones saying global. It does it by default. So anytime we come back from that call, we have to go to the main thread. But here, we're the ones explicitly saying to go global. That's why URL session is even a better, more API than this one. Because the minute I say URL session, grab me a URL, it goes asynchronously.
So without that, the whole new control of all is on the main thread.
Yes, yes. And then there's different places. We could talk about thread safety, not today. There's a lot of stuff with threads we'll talk about. But for today, I just wanted to introduce what concurrency means. So at the end of the day, we walk away knowing that concurrency means my user could scroll and click on the load image at the same time. That's it. That's like all what we need to know today. Yes, sir.
So when we do this, and the user presses the load image once, load image is still there. What happens if
Well, we could go a step further.
Okay.
When they click load image, ideally you want to disable it.
Okay.
Because right now the user could make multiple requests,
Right.
right? You see, that's a question?
That's the biggest problem.
Yeah, you need to stop that,
Okay.
right?
How do I show them like something's loading?
A UI activity indicator. We'll take a look at that tomorrow.
Okay.
Today I don't want to introduce too many new things. I only want to talk about concurrency.
Alright.
But ideally you would have a UI activity indicator on your image. So it loads, like it spins, and when the image is ready, you take it away. Yes.
So right now, when sync is used for the dispatch,
Async. We did async.
no, but I tried it with sync.
Mhm.
It does the same thing. So if multiple things are happening, then
Sync will work just because it's not on the main thread. I
So
don't.
if I had something else happening in there, it would still work the same way.
In where?
Because you're setting the image in dispatch.
Sync right now blocks everything. If you say sync on you said probably, where is it? Here, let me fix my code. Take that out. Take that out. Take that out. Take this out. Go back here, right? That's what you have? And you said you did sync instead of async, right?
Yeah, and right now, it works the same as
It's going to work the same. It's not going to crash because you're coming out of the background to go back to the main.
Okay, but what I'm saying is like if there was another thing that you were setting in there, and it said sync, would it like?
If it was anything else you're doing in here would be UI. So they all would just work at the same time. Yeah. They all do work at the same time. But if you're doing, be careful with sync here. So what Chelsea is saying, so she does sync, which is fine here. But be careful with sync, because if you're syncing on the main thread, and it's the main thread already, it's going to crash your app.
So it's better to just do async for most of it. Like most of the time, it's always just better to do async.
Exactly, unless you explicitly you know that you want to block something, or you know there's no deadlock.
So it's like something where you would specifically want to block something, like let's say like put in a password or put in or like an email, like one of those required fields. Like
Even that you don't want to block, right?
you know?
There's no reason. I mean, there's other ways, there's other mechanisms to have there to allow the user not to go to a different page, right? Like for example, if the fields are not filled, your button will be disabled.
Okay. So what would be an instance where you would use?
Maybe a database access, for example. Like you want to stop everything from running unless the user has access to the database.
That would be like a network.
A network I/O thing, or it's heavily resourced. You want to stop all activities until that resource is back. But you'd have a spinner to let the user know that something is loading or something like that. Yeah. Yes. Say that again. Sorry, guys. 1 second. Yeah, global, it's used interchangeably. When I say background, it's everything on global, right? Because at the end of the day, it's off the main thread, it's on the background. Main thread is the UI, it's dispatch main queue, yes. Cool? At the end of the day, you guys will end up just doing global because the priority it's not that much of a difference unless you're doing some background task where you really want it to be a low priority. Because most times you see in code bases, it's only global, there's no QoS specified. Global by default is pretty much good. Yes, sir? That's about the lesson there. I just want to stop the lesson here, but yeah, exactly. Any questions before we move on? Yes?
Do you use the perform selector
In what context?
instead of dispatch queue, not main?
Perform selector performs some function, right? Like what does that do? But I'm losing. Perform selector says perform some action.
Yeah, but then you can tell it to do on the main thread or the background thread or whatever thread.
Dispatch queue is the API you should use to do GCD work set. Okay? Perform selector, you want to perform some action on some thread, that's fine. But dispatch queue is the class you use to dispatch what you want to dispatch. Okay? How we do with concurrency? Do we all understand the definition of what it is? Any ambiguity there? We know the difference between synchronous work and asynchronous work. We know the difference between quality of service priorities. There's a thin line between them. That's why I slacked. That's why I made a screenshot, right? If you're in doubt, just use global without a QoS. Everybody with me? If you're in doubt, you could simply remove the QoS level here.
So QoS is just priority, right?
Yes.
Okay.
It basically puts it in line on the queue. Like we haven't spoken about queues, but it's a priority queue,
Yeah.
right? Different numbers.
So like one should be done beforehand.
Yeah. So if there's space, this is the first one that gets off the queue. The queues. It's almost like you have to talk about the queue before, queue before you talk about that, but that's fine. Yes.
And for these QoS types, if I'm understanding it correctly, does Swift have its own like priority system based off what you put in?
Yes. That's the system. The system handles that.
If you, let's say you were making an app and you were just like, I really want the image to load. Like, I really want this thing that normally has a slower priority for whatever reason for the purpose of your app to run quicker.
Then it would be user initiated.
Then you would.
Yeah. And then you could do prefetching if you really want the thing to happen quicker. There's other things you could do there, like prefetch your images before the user sees that view controller, so they're ready. Or you could do batch fetching. There's a lot of different mechanisms there. Yeah.
So if you don't use QoS, it says that queues are FIFO, the first in, first out. So does that mean like depending on how you code it, like line order, or what does it mean by the first?
It's not guaranteed for completion. It's the way it goes in. So like you're on a queue, like yourself on a queue, Adani's on the queue, right? You'll go in first. That doesn't mean your work will be done first.
But how does like the system know what queue goes in first?
Based on the priority.
But like let's say you don't use like
If you don't use it, it's going to be default. The default is almost like background. Like the default is actually between user initiated and utility. So figure priority 2, 3. And again, based on thread availability on your cores, it's going to decide which one it is. But if it's a default, it's 2 or 3, between 2 and 3. So if you want to be more explicit, then you use one of the QoSs. Does that make sense?
yeah, I was just wondering how would the set priority related to QoS?
Between 2 and 3, user initiated and utility. Between those and the amount of space you have available. No space, but cores available, right?
Oh, so these four that we have numbers like user.
Think about them having numbers, yes. Where user interactive,
User interactive is what, number one?
Priority
Is
one.
the highest priority?
yes.
Okay.
And then the lowest is background. Because background is like database work.
We don't start at 0, we start at
Yes, think about it as one, yes. Any other questions? Okay,
For
cool.
the data thing,
For the data thing.
you didn't have to use about that.
Sorry.
Functions of URL, you didn't have to use like dot and then.
You could do that in it, right? You could do that in it, or you could do, they're both available for you. You could do that in it like this. That's what you're saying?
Yeah.
In it. This is older, I'll just do the parents. It's cleaner. But you could do that in it, contents of. Right? But this is cleaner to move the dot in it. Because you know it's an initializer, and it's more swifty to do that. Cool? Any other questions? Any other questions? Okay. That's the introduction for concurrency. I'm not going to talk about deadlocking right now, but I'll mention what deadlocking is. Deadlocking is you have, you're on the main thread. Like right now, we're in view did load. I'm on the main thread. If I try to make a synchronous main thread call again, the two of them will be racing for position and the app will crash. Okay, I won't get into it right now because for the purposes of today and what we're doing in Unit 3, we don't need to talk about deadlocking, but we'll come back to deadlocking and more concurrency terms later when we get closer to job search. Like we'll talk about mutex and race condition, because you could get asked those things on interviews. But right now, if I start introducing that, right, there's no context for it exactly. Okay, everybody? But keep in mind that we have the documents. Please go and read the one on the lesson. Go read that more in depth there. But for now, for Unit 3, all what we need to know is if we're doing UI changes, we go on the dispatch main. If we're doing image processing, data processing, we go on a global queue. That's it. And know what synchronous and asynchronous is. Cool? All right. So we'll start here. Thank you.